So for number 2, to complete the missing information on each page, if we look at something from the other category, well, it was a C and E. C, I think, is the most relevant because it's a perfect square. It's an equation that we are familiar with. If I know that that is 3 squared, 4 squared, this would be 5 squared, or 25. 6 squared is 36. 7 squared would be 49. And so then the sequence in words described, square each consecutive term. If this is 0, then 0 squared, call it squared, or square consecutive numbers. This is still going to be 0. The first, you square 1, you get 1. You square 2, you get 4. You square 3, you get 9. You square 4, and you get 16, and so on. That would continue. The ones that we're going to be more familiar with are the well, something like this. And we looked at this yesterday. If you look at just the sequence here for B, you got 3 to 6 to 12 to 24. You're multiplying by 2, so we have a 48, we have a 96, and then we would have a a 192. Okay, and so on. So if you're multiplying going that way, you're actually going to be dividing heading this way. So it makes it a little bit of a challenge here just momentarily until you think about, okay, 6 divided by 2 is 3. 3 divided by 2, we'll leave it in fraction form. Just call it 3 over 2. Okay, we're multiplying by 2 in this case as we go. Now the equation that we need here, we introduced this one yesterday. The initial value is 3 over 2, but we're multiplying by 2 each time, and we raise it to the n power. Okay, so in this case here, the 0 term is going to be 3 over 2. The first term is what you get when you plug in 2, but it's that first term of the sequence. That would be a 3, and then the second, the third, and the fourth, and so on, are going to be 6, 12, and 24. Okay, so those are they fall into that plus multiply category. And these here, consistency-wise, O, and it's just the one I had on top, we're subtracting 10 each time. So if I'm subtracting 10 each time, this is going to be a negative 27, negative 37, negative 47, and so on. Over here, we're adding 10 to go back the other direction, so this is up to 23. So if I subtract 10 and so on, and I'm subtracting 10. From 23 in the previous one, I guess I was multiplying by 2 from an initial value of 3 over 2. So we're subtracting 10 from 23 and on and so on and so on. The equation, this is just a linear equation. So it's a negative 10 times n plus 23, where 23 was our initial value, and each time we move forward, we're subtracting 10 from each one. So the 0 term is 23. The first, second, third, fourth terms are going to be 13, 3, negative 7, and negative 17, and so on. I just realized I didn't plot all the other ones, but 23 is kind of in the neighborhood of this, right? And then over at 1, you're up to 13, and so we're going to hang out in these neighborhoods here, right? There's your 3. Negative 7 is going to be actually down in the lower region, and then negative 17 would be kind of down there. But you can see this trend. You don't want to connect the dots. So as if I can address this, plotting the points, I don't think it's going to be an issue for anybody. But it's, do I connect the dots, and do I end up going back into the negative realm or whatever? But this is essentially the way we want to leave that.